Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
We can stop HIV, Iowa.
One key step? Getting tested for HIV.
An estimated 14% of people in Iowa living with HIV don't know their status. The CDC recommends everyone get tested for HIV at least once in their lifetime, or more often when needed.
So testing is important.
Yes! Testing is the only way to know your status. It's the first step in getting additional HIV prevention services or HIV care.
Find out more at stophiviowa.org.
This is SpaceTime Series 24, Episode 98, for broadcast on the 1st of September 2021. Coming up on SpaceTime, Ingenuity completes its 12th flight on Mars. NASA announces the science goals for its Dragonfly helicopter mission to Titan, and new details on fast radio bursts. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Ingenuity helicopter has completed its 12th flight across the surface of the red planet. The tissue box-sized rotocopter, which is scouting the route ahead for the agency's Mars Perseverance rover, flew at an altitude of 10 meters over the South Theta region, covering a distance of 450 meters in 169 seconds. Mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California, say Flight 12 was very similar to Flight 10, with the tiny 1.8 kilogram twin-rotor chopper again examining a surface feature known as the raised ridges in order to gain additional data on the formation. Perseverance is gradually moving northwest across the southern ridge of Cetia and is expected to meet up with Ingenuity in coming days. Ingenuity landed on Mars back in February, attached to the underside of the Perseverance rover, undertaking its historic maiden flight on another planet on April the 19th. Since then, it's logged more than 20 minutes of Martian airtime, covering over 2.2 kilometers. This is SpaceTime. Still to come, NASA announces the science goals for its Dragon helicopter mission to Titan, and new details help unlock some of the mysteries of fast radio bursts. All that and more still to come on SpaceTime. Following in the wake of the highly successful InSight rotocopter mission to the red planet Mars, NASA's released its primary science goals for its proposed Dragonfly helicopter mission to the Saturnian moon Titan. Titan is Saturn's largest moon, the second biggest moon in the solar system, and it's larger than the planet Mercury. In fact, the 5,150 kilometre wide world is 50% larger than the Earth's moon, and some 80% more massive. More importantly, it's the only world in the solar system other than Earth where clouds rain liquid onto the ground, forming streams and rivers that eventually flow into lakes and seas. But unlike Earth's water-based hydrological cycle, Titan's rains are made of methane and ethane. On Titan, temperatures are so cold, water is frozen so hard it forms the bedrock. Titan's atmosphere is about 10 times as thick as the Earth's, and it's primarily nitrogen laced with methane and ethane. NASA's Dragonfly mission will send a rotocraft to Titan in the mid-2030s. Its newly released primary science goals will include searching for chemical biosignatures, investigating the moon's active methane cycle, and exploring the prebiotic chemistry currently taking place in Titan's atmosphere and on its surface. Though NASA's Cassini mission studied the ringed world of Saturn and some of its moons for 13 years, the thick methane atmosphere of Titan allowed this moon to retain much of its mystery, including key details about its Earth-like morphological structures, including its dunes, lakes and mountains. Cassini's Huygens lander probe, which parachuted down to the surface of Titan in 2005, was equipped with predominantly atmospheric science experiments. That's because mission managers weren't sure if it would survive the landing. It did, but really apart from a few images, all we really know about the Titan's surface is that the place where Huygens landed had the consistency of wet sand. Dragonfly will be the first mission to explore the surface of Titan in detail and identify the composition of its organic-rich surface. The plan is for Dragonfly to spend a full Titan day, the equivalent of 16 Earth days, at each location, conducting a range of scientific experiments and observations. It'll then fly to a new spot and repeat the process, slowly building up a picture of this distant world. Titan's low gravity, just a seventh that of the Earth, and its thick atmosphere, 4 times denser than the Earth's, makes it an ideal place for a rotocopter vehicle. Also, it has a relatively quiet atmosphere, with winds far lighter than on Earth, and that's going to make things even better. Many of the science questions Dragonfly will try to answer will address prebiotic chemistry. That's because chemical compounds which formed on the early Earth are also forming in Titan's atmosphere today, making it a great analogue for the early primordial Earth. Dragonfly's search for chemical biosignatures will also be wide-ranging. In addition to examining Titan's habitability in general, scientists will be investigating for potential chemical biosignatures past or present, and they'll especially be looking for water-based life that might be using hydrocarbons as a solvent, such as within Titan's lakes, seas and aquifers. This is SpaceTime. Still to come. New details continue to draw open the curtains on fast radio bursts, and a Russian Soyuz delivers more OneWeb satellites into orbit. All that and more still to come on SpaceTime.
See care in a new light at Madonna Rehabilitation Hospitals, where top medical minds lift you up, where the very best in specialized rehabilitation brings out your very best, where over 60 years of breakthroughs in research and technology spark your newfound strength. In our world-class hospitals, this is something greater than rehabilitation. It's renewed strength for life. Learn more at madonnarehab.org.
Astronomers are continuing to slowly unwrap the secrets of mysterious objects known as fast radio bursts, ephemeral, powerful blasts of energy from deep space, lasting just a few milliseconds. Now, 2 teams of astronomers studying the nearest fast radio burst, or FRB, ever detected have reported their findings in separate papers. Both groups were studying FRB 2018-0916b, a fast radio burst originally discovered in 2018 by CHIME, the Canadian Hydrogen Intensity Mapping Experiment Telescope. The burst originated in a galaxy very similar to the Milky Way, located some 457 million light-years away. One team of astronomers reporting the astrophysical journal Letters were able to measure the radiation from the burst at the lowest possible frequencies ever detected, while the second team, reporting in the journal Nature Astronomy, were able to examine the bursts in greater detail than ever possible before. Both articles are providing new information about these mysterious events, but they're also raising new questions. Astronomers detected their first fast radio burst back in 2007. Now, initially, all the fast radio bursts that were discovered appear to be solitary events bursting just once and then never again. And that led many scientists to speculate that these powerful events from deep space could be associated with supernovae, the cataclysmic explosion of a star as it dies. But then later on, astronomers began finding fast radio bursts that would repeat at regular intervals. And that's raised the possibility that there could be 2 different types of fast radio bursts. But as to their exact cause, that's still not clear. Although there is growing evidence linking the repeating type of fast radio burst with highly magnetic neutron stars known as magnetars. FRB 2018-0916b has a burst pattern that repeats every 16 Earth days, 4 days of bursts followed by 12 days of relative quiet. And that predictability makes it an ideal object for researchers to study. One team of astronomers observed the FRB using LOFAR, the European Low Frequency Array, a network of radio telescopes. They tuned the LOFAR antennas to between 110 and 188 MHz, and that's just about the lowest frequencies the telescope can receive. Surprisingly, they caught 18 bursts, an unexpected result because fast radio bursts usually transmit at much higher frequencies. The authors now suspect that this fast radio burst is emitting radiation at even lower frequencies, and they'll be looking to confirm that in the near future. They found the low-level radio emission to be quite clean and arrived later than bursts with higher radio emissions. One of the study's authors, Jason Hessels from the Netherlands Institute of Radio Astronomy Astron at the University of Amsterdam, says that at different times this FRB would produce bursts with different radio frequencies. He says that could be explained if the FRB was part of a binary star system, resulting in it being in different positions at different times as these enormously powerful bursts are generated. Meanwhile, the second team, led by Kenzie Nemo, also with Astron and the University of Amsterdam, used the European Very Long Baseline Interferometer network of radio telescopes, which includes one of Astron's 12-metre Westerbroek telescopes and the 100-metre Eifelsberg telescope in Germany. They looked in the greatest detail ever at the so-called polarised microstructure of the eruptions. The authors saw that the burst pattern varied from microsecond to microsecond. They speculate that this variation might be caused by a dancing magnetosphere enveloping a neutron star. Strong support for the magnetar hypothesis. This report from Astron and the University of Amsterdam.
The depths of space hold many mysteries, and around 12 years ago, astronomers stumbled across a new one. A single strong flash of radio light that lasted for just a few milliseconds. This cosmological signal was named a fast radio burst, or FRB for short, and whatever had produced it must have been exceptionally energetic. What is impressive is that FRBs are not rare. In fact, hundreds of them have now been discovered. Astronomers are still debating what the most likely source of these signals could be, and it's quite possible that nature has created something we have never before imagined.
One of the problems that we have is that we often only know the positions of FRBs very approximately. To get to the bottom of this astrophysical mystery, we need to pinpoint the locations of FRBs very precisely, and to do that, we need to use a very large and sensitive radio telescope.
Because astronomers cannot build a radio telescope big enough, they use multiple telescopes across the globe to observe at exactly the same time. This technique, known as Very Long Baseline Interferometry, or VLBI, effectively turns all the individual telescopes into one big one.
In 2017, we used the most sensitive VLBI array in the world, the European VLBI network, to study an interesting FRB, which appeared to repeat in an unpredictable way. This enabled us to localize the FRB to a dwarf galaxy in a region where the stars are formed.
Since then, astronomers have localized 3 more FRBs, but none have been observed repeating. These FRBs were all found in massive galaxies, radically different locations from the first known repeating FRB. This raised the question whether there is a fundamental difference between FRBs that have been observed repeating and those that have not.
With only one localized repeating FRB, it was difficult to draw conclusions about them. But now we've had the opportunity to study a second repeating FRB. We observed the FRB with 8 EVN telescopes across the globe and conducted follow-up optical observations with the Gemini North Telescope in Hawaii.
The astronomers collected terabytes of data and observed 4 bursts of the FRB. They found that this repeating FRB was in a star-forming region of a relatively nearby spiral galaxy, whose properties are similar to those of our own Milky Way.
The location of this FRB is radically different from the previously located repeating FRB that was found in a comparatively puny dwarf galaxy, but also different from all previously studied FRBs. Does this diversity mean that different types of sources can produce FRBs?
Or is it possible to devise a single model to explain the different host environments?
By finding FRBs in a diverse set of galaxy types, now including galaxies similar to our own, astronomers are again scratching their heads. However, the relative proximity of this new FRB, which is only 500 million light-years away, is a unique opportunity to study these phenomena, and hopefully finally unveil what these mysterious signals are from the depths of space.
And in that report from Astron, we heard from Jason Hessels from the University of Amsterdam, Benito Marcotte from JIVE, that's the Joint Institute for Very Long Baseline Interferometry, and the University of Amsterdam's Kenzie Nemo. And this is SpaceTime. Still to come, Soyuz delivers more OneWeb satellites into orbit, and later in the science report, a new study has looked at why homosexuality has survived and has never been bred out of the human species. All that and more still to come on SpaceTime. Russia has launched another 34 OneWeb broadband satellites for the London-based company, increasing its current constellation to 288. The launch aboard a Soyuz 21B rocket equipped with a frigate upper stage had been delayed by several weeks due to technical issues with some of the Florida-built satellites. The flight from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan was the 9th launch for OneWeb. The mini-fridge-sized satellites are being placed into 1,200-kilometre high orbits. OneWeb plans to deploy an initial constellation of 648 spacecraft by next year. In order to achieve this, the company will need at least 10 more Soyuz rocket launches, using facilities at Baikonur, Vostochny and French Guiana in order to complete deployment of the initial block of OneWeb satellites. This is SpaceTime.
It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that younger kids are more likely than teenagers to pass on the COVID-19 virus to caregivers and siblings. The findings, reported in the Journal of the American Medical Association, are based on a study of 6,280 Canadian households. The authors found that kids aged 3 years and under had 1.43 greater odds of infecting others within their household than did teens aged 14 to 17. Researchers also found some evidence suggesting that kids aged between 4 and 13 were also more likely to infect family members, but to a lesser extent than toddlers. The World Health Organization says more than 8 million people have been killed by the COVID-19 coronavirus, with more than 4.5 million confirmed fatalities and over 215 million people infected since the deadly disease was first spread from Wuhan, China. A new study looking at genetic variation has identified a possible reason why same-sex sexual behaviour may have persisted throughout human evolution. The findings, reported in the journal Nature, found that genetic variations linked to same-sex behaviour are also found in so-called straight people. And when they do occur, those straight people tend to have more sexual partners. Researchers say this could mean that straight people with these genes tend to have had more children in human evolutionary history. And this boost in mating is enough to outweigh the loss of reproduction among the same-sex group, thereby resolving the evolutionary puzzle. However, the authors note that their findings should be interpreted with some degree of caution, as the data is only from people with European ancestry in the UK and the United States, and the number of straight sexual partners people report today may not necessarily reflect what happened in the past. Paleontologists have unveiled a new species of Cretaceous period feathered dinosaur related to Velociraptor. The metre-long dromaeosauroid theropod named Papyrolopi walked the Earth between 72 and 66 million years ago. It was discovered at a dig site in a rural district in the Brazilian state of Minas Gerais. A report in the journal Papers of Paleontology says the specimen consists of a partial upper jawbone with associated teeth and a portion of lower jaw. Well, new cell phones from Samsung and Google are on their way. Technology editor Alex Harov-Reut from ITWire.com says the new Samsung Fold is now in its third generation.
Well, they've got their new Fold 3 5G and their Flip 3 5G. That's a third generation of foldable screen devices. The first one to have IPX8 water resistance. It's not dust resistant because the folding mechanism does enable dust to go inside, but they do have brushes inside that can brush some of the dust out. The screens are more power efficient. In fact, Samsung has a whole galaxy for the planet to move towards creating all sorts of power efficient systems, and their phones using less power when they're on it. They're no longer shipping a power brick inside with their phones, which enables them to save money. But we also see some pretty big price savings for the both devices compared to what they were charging last year. Last year, the Fold 3 was $2,999. So that is now down to $2,499, and the Flip was nearly $2,000. It's down to $1,499. You pay about $100 more if you want to double the storage from the 128 to the 256 or the 256 to the 512, depending on whether you're getting the Fold 3 or the Flip 3. And of course, Samsung also has its ecosystem of Galaxy Buds 2 and its watches. And Samsung tries to copy Apple as closely as possible in having a strong ecosystem so that the buds, which go into your ears, work across phones and watches and tablets as smoothly as possible. And Samsung's biggest competitor was Huawei until government's ban on them using Google. And of course, speaking of Google, we will soon get the news about the Google Pixel 6, which will be totally redesigned. But there's also heavy rumors that there's a Google Pixel Fold, which will be a folding phone, presumably using Samsung's display technology. That's yet to be seen. But the fact that we now have the third generation of screen tech with bigger screens on the front and inside, we have a camera that's under the display, so you don't have the little notch. Clearly, the quality from a camera without a notch is not as good as when the notch is unobscured by the screen. But they've launched it, and it's pretty amazing. So it'll be interesting to see when Apple finally decides to go down the folding path, probably still a couple of years yet. But by then, the folding screens will be very mature. And already in the third gen, that's pretty mature. And you just have to have $1,500 to $2,500 to be able to buy these devices, but that's why you have payment plans that lets you pay them off every month over a couple of years.
Now, when you and I first met, you impressed me with your visions of the future, especially when you talked about everything coming together. Your phone will be your music center, will be your camera. Convergence, you called it. And you were proven to be absolutely correct. This was years before the rest of the world seemed to catch on to this idea. Where are we going now with all this? Will this replace things like the iPad? Is that where we're going as a replacement for the iPad, or will there always be room for something like that?
There'll always be room for something with a larger screen. I mean, there were rumors that Apple was going to make an iPad with like a 20-inch screen, much bigger than the 12.9-inch screen that they have today, which is the size of your standard sort of 13-inch laptop.
Yeah.
The current Samsung Galaxy Fold unfolds to more or less the size of an iPad mini. So it really just depends on the sort of screen size you want. Yeah. You know, we will have bigger tablets that will fold into thinner and smaller devices, but then you have the issue of thickness. There was a movie with Vin Diesel called Babylon AD a few years ago, and he took out what looked like one of those old-fashioned folding maps from his bag, and as soon as he unfolded it, he could then start swiping along the map as though it was a touchscreen, and you could zoom in and zoom out. And eventually we'll have e-ink that is as foldable as regular paper. They're already talking about e-displays that can display in full color. So that future is probably still at least a decade away, but we will eventually have tablets. If you watch the Westworld TV show, they had these tri-plane tablets that could fold into the size of a standard mobile phone today, but unfold with the trifold into a normal A4 sheet of paper. So there's a lot of work being done in this. At the moment, we just have limitations of technology. But the convergence play was something that Nokia used to claim it was the world's biggest maker of MP3 players, voice recorders, digital cameras, video cameras, and mobile phones. And now, of course, that's Apple and all of the Android makers. So that convergence. I remember seeing an ad that has been shared on social media and the internet many times showing Radio Shack or Tandy, and they had CB radio and cassette players and CD players and VCRs and video cameras, all these different things. Yeah. Just about everything on the page can now be done even with a $100 smartphone with pretty amazing quality compared to the past. So we've come a long way, and eventually it'll all be somehow wirelessly connecting directly into the neocortex, your brain. Hopefully we won't have to have anything plugging into the back of our heads like in the Matrix. And the stepping stone to all of those is going to be the VR and AR glasses. The AR glasses especially that are going to overlay a digital map, digital information onto the real world, so much so that in the future, unless you have one of these pairs of glasses on, you won't be able to interact with the real world, that is the real digital connected world, properly without having these sorts of glasses on. But we're still, at least a decade away from that as well. So all the good stuff's always at least a decade away. And we say, oh yeah, it's still a decade away. So
That's Alex Zaharov-Reutt from ITWire.com. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.